Presentation comes from the oil field. Mr. Tapas Chakraborty from Gulf Oil Lubricants India Limited will be delivering a lecture on upkeeping of injection molding machine and energy efficient with superior liquid technology. Mr. Tapas Chakraborty is a BE Mechanical from NIT and MBA from IMT with more than 20 years of industrial experience. He is also a certified machinery lubrication professional from International Council for Machinery Lubrication. He has worked as product manager in Lubrisol, sales manager in Fuchs Lubricants, and technical manager at Raj Petro. Currently, he is the DGM for technical services of Gulf Lubricants. Please take over, sir.
Good evening all, and thank you Dr. Manmohan for a nice presentation. So from morning we have many sessions on energy efficiency and sustainability, and so my session is
the world's first commercial catalytic process in 1980.
So my presentation is also on the same ground. I will not take more time probably. So I'll start my presentation. So these are the topics what we are going to cover this session. Why this energy efficiency in the hydraulic oils are important, how it is going to affect the savings part and all. And I'll give a brief introduction about our organizations and how the hydraulic oil works in the injection molding scenario, or a brief about our range of products in the hydraulic oils. And on the last, I will going to show one case study what we have done on the energy efficiency. So that's a very interesting study what we have done. So this is what last year, similar time, we have presented in the same forum about the hydraulic oils, what they do in the injection molding. And that time I raised one of the major concerns on hydraulic oil about the contamination. So hydraulic fluid is such a fluid which goes on many parts of the injection molding machines, and that's why the contamination is one of the very critical aspects to cover up. So this was my last presentation in this forum. So now coming to the energy efficiency, as I was talking, why this energy efficiency is important for particularly for injection molding, because it's a very energy consuming process. A lot of energy gets consumed. And as we understand that it affects or impacts both financially as well as for the environment. So that's why this is the topic of the hour, that energy efficiency. And the potential savings are also considerable. If we can really work on that energy savings, energy projects, so that can give lot of savings to the organizations. So that's why this study we have conducted. And while doing this study, few of the things how we have started this study actually. This is the performance characteristic line, or we call it PCL. So in this PCL, what actually we have plotted is the production volume by electricity being used, or the power is used. Okay, if we can plot month on month of any particular user, so we get a graph like that. And if we extrapolate this graph, we get this base load and the variable load. Because when we talk about the energy in this manufacturing process, it is a variable aspects. There is a base load and there is a variable load. And the slope of this graph, of the PCL graph, gives the variable load. One more thing we have plotted here, that is or we have calculated here, the correlation coefficient, which is the R² value. And from the statistical point of view, if this value is more than 0.7, then this result and the consistency of this study is very good. And if it is less, then it is not so good. So we found in this study it was more than 0.9. So which gives us a confidence that yes, in this particular unit, if we conduct this study, we can get a very good result which can be extrapolated in the other places. So I will start with a brief about our company Gulf Oil. It's a legacy of 120 years. So you can give a 1-minute video, please. You can start.
Since its inception in 1901 at Spindletop in Texas, USA, Gulf Oil's journey has been about success and leadership through constant innovation. It is credited with the opening of the world's first drive-through service station in Pittsburgh, USA in 1913, the world's first commercial catalytic process in 1918, and the world's finest motor oil called Gulf Pride in 1928. In the late 1980s, Gulf was acquired from Chevron by the Hinduja Group, one of the largest diversified business groups in the world. Gulf is now under the flagship of Gulf Oil International, which is led by Mr. Sanjay G. Hinduja. For over 100 years, the Gulf brand has successfully expanded its business in various sectors. Today, it enjoys a strong presence across the globe and is recognized as one of the largest independently owned lubricants companies in the world. Manufactured worldwide, its products are sold in over 100 countries. The products are formulated as per the highest global technology standards provided by Gulf Oil Lubricants and carry approvals from leading global original equipment manufacturers and standard bodies.
Thank you for the video. So most of the things what is there in this slide has been covered in the video. Only the top right hand corner, there are 2 plants are showing. So we currently have 2 blending plants in India. One is at Silvassa and another is at Chennnai. So the right hand side pictures are showing that. And below that there is a global technology center which is also at Chennnai. So where we do a lot of this kind of studies and research work. We have a world, all the overall India network. We have depots across all states in India. We have our corporate office at Mumbai, and we have 4 regional offices in different regions now. We have a very big channel networks, and more than 55,000 dealers network is there across India. And we also have more than 350 infra, mining and fleet customers also. Now coming to hydraulic fluid, what they do in this system, okay. So we know all that hydraulic fluid transmits the power, and the transmission happens that from the pump, it starts pumping to the actuators where it does the work. It moves the mechanical parts basically in the system, and it provides the pressure. So this is the very basic of hydraulic work, and this basic is important to show it here because based on this only we worked on the energy efficiency part. It provides the lubrication, definitely, that is one part of the lubricants. So it prevents the wear and tear, and if it happens any kind of contamination, it brings back to the filters. It prevents steel and copper corrosion as well. And if any heat generation happens during the process, it gets cooled in the cooler system. So this is what a hydraulic fluid does in the injection molding system or any other hydraulic systems. But there are a lot of changes happen in hydraulic systems, especially when we talk about injection molding machines 20 years back and now the injection molding machines what are coming in the market. There's a lot of changes. There are changes in the system design. There are changes in the operation pattern also. Some cases, these designs like the hydraulic oil reservoir has come smaller, or more and more servo control valves are being used. Pumps are coming, very high capacity pumps with very tight tolerances, and some cases finer filtrations are coming. So it all happens, and there is also a demand from the user that they want an extended drain interval of the oil. So this all affects the hydraulic oil. The demands much more. Okay, the oils are coming under stress, and they go on having this oxidation and thermal stability. So that is very important for the oil while designing the products. And there is also a demand for energy efficiency. So that is the need of the hour at the moment. So this is the range of products. Gulf enjoys a very exhaustive range for the hydraulic oils. We have our brand for Gulf Harmony. So Harmony is our brand for hydraulic oils, and we have the entire range of products under our portfolio. Some of the products are also having a zinc-free kind of technology, which is a latest kind of environmental friendly technology, ashless technology basically. And we also have a super clean range of products. Like as I told, contamination is a very critical part for the hydraulic oil, contamination control basically. We supply to major OEMs. Also we have the approvals from these OEMs, and we supply to a wide range of operation to different industries. We have the approvals of pump manufacturers like Danielson and Bosch Rexroth also. Now coming to the energy efficiency journey, I choose the word journey because it really has a journey, because we also understood a lot of things during this process. So from a owner's point of view, it is like a total cost of ownership. When they buy a machine, when they buy a system, when they buy oils to run the machines. Okay, so purchase is one thing. Second thing is maintaining the things, maintaining how they maintain the systems. So when we talk about maintenance, the first thing comes is the durability. So hydraulic fluids durability, if we talk about, there are different tests are available in the market, in the industry basically. So a lot of ASTM tests are available, DINS tests, ISO tests are available, and even pump manufacturers also define a lot of pump tests to check the durability of the oil, whether it is doing the purpose, the lubrication part basically, the wear and tear and other things. So this durability can be checked with those standard tests. When we talk about running, so then it comes the efficiency part. Okay, now when we talk about efficiency, there is no industry standard tests for energy or the hydraulic oil efficiency to measure in that way. So somebody talks about efficiency like productivity, or how quickly the cycle time can be reduced with those hydraulic oils and all. Somebody talk about energy consumption, even they talk about work done how per unit of fuel, and somebody talks about temperature reduction. So there are different kind of definitions comes from the end users, as because there is no standard industry tests are available. So this gives us a challenge when doing this study, that what we should measure in that way. And when we understood this efficiency we have to do, we understood that our regular off-the-shelf product may not able to give the right kind of results. So that's why we formulate a new type of hydraulic oil, which can give the efficiency improvement as well as the durability. So both can be measured. So we selected an incumbent fluid, which is a market leader kind of products in this industry we choose. And then we formulate two candidate products of ours. One, keeping the same viscosity grade. Okay, so the incumbent fluid is also a VG46 type of oil, hydraulic oil. We choose same VG46 oil. Another oil which selected based on our studies at the lab and different studies what we have done so far, a 32 VG oil, which is a one grade below the viscosity grade of the existing product. But if you can see the viscosity index, which denotes basically, if you see the temperature at higher temperature, like viscosity is at higher temperature, like 100 degrees, the VG46 regular monograde product is having a viscosity close to 7. But our 46 viscosity oil, viscosity at higher temperature is higher, almost close to 9. That's why we choose a viscosity grade 32 with a very high viscosity index, keeping the viscosities at higher temperature similar, 7. So both the oils were energy efficient kind of multi-grade products, where if you see the formulation or the composition of the product, viscosity modifier is a kind of additive which we have added in these formulations. Now how this energy efficiency can be derived. Okay, I am just trying to give you some ideas how this energy efficiency can be achieved. So when we see a flow, there is a primary flow and there is a secondary flow. Primary flow is major part of the fluid which flows along the pipe basically, and the secondary flow is something which is against this primary flow, or which is a different direction from the primary flow. And why it happens? It happens because if there is a bend, which is obvious in any system, obviously there will be some bends in the geometry. So when there is a bend, there are different direction flow starts to happen. And these secondary flows, what happened, they mix with the slow moving and the fast moving kind of flow inside the pipe. So when we see the details in this picture, you can see that there are some flows which is along the pipe, there are some flows which is opposite to the direction, and when they move each other, that causes a fluid momentum loss basically. So there is a energy loss happening, okay. So which are the location it can happen? It can happen during the bends, it can happen in the valves, filters, even the actuators. So these are the parts of any hydraulic system where this kind of secondary flow can happen. And this can create a fluid momentum loss. So if you can see here, when we were doing this study, so the left side picture is basically there is a turbulent flow. So when we talk about, I'm not going to give details about the Reynolds numbers and all those things here. But if you see the turbulent flow here, so there is a loss in the momentum. And the right hand side, there is a laminar flow. So we choose certain additives, technology and all, and we find out this if the flow is like that, then there is a less flow limit loss, and the lower traction coefficient. So that also helps in the energy efficiency. And we also measured the shear stability loss, because the moment you use some kind of polymers to give a high viscosity index of any product, there is a chance of shear loss. So we choose certain additives of high viscosity index. Those are having very good shear stability. Okay, so that we have tested in our laboratories. And obviously pump wear loss, that is the durability part, which always are taken care. So we did the field performance test. So you must be wondering what this map is doing here. So to show you that we did this trial at Ahmedabad, near Ahmedabad one place. The customer was Maison Plastic Industries near Ahmedabad. And we did this in Windsor machine, a model H250. And the sump was around 400 liters sump, hydraulic sump, having a servo-driven motors of Rexroth. And the mold locking pressure was around 200 bars. So these are some of the details about the machine where we did this study. While doing the study, we measure all these things. We measured the ampere signals to measure the current. We did collected the details about the volt signals. The start-stop triggering has been done by control units. And then we measured the temperature, pump inlet and outlet temperature, pressures. And also we check the ambient air temperature sensor. So all these sensors are put in the machine to measure this data. These are some of the glimpses of the site where we did. This was a finished product, basket, pink color. And we did sample the oils during the trial after flushing this. And also these are the data loggers where we captured the data for all three phases, current, voltage, cycle time, everything we have been monitored and put in the graphical mode. And this is the data what has been derived from that. And what we have seen that our first candidate, which was VG46, didn't give much of energy efficiency. But the VG32 product, the second candidate product, has given a 3.4% total power consumed and 3.8% savings in the energy per parts. So this is the data we captured during the trial phase. Now someone may think that what is this 3.8% after so much of putting sensors and calculations and studies and all, we got only 3.8% of savings. Just to show you how this impacted. Okay, what was the benefit? In the morning, Dr. Banerjee told that everything comes under cost benefit. Unless we do the cost benefit, nothing ends there. But while doing this benefit analysis, we did the cost analysis for both financial as well as environmental benefit. This 3.8% gives 25,000 rupees per machine in a overall year of 5 years period. Because these machines runs almost throughout the day, almost if we say 20 hours per day running, this gives per machine can give 25,000 difference. While calculating this, I have taken the extra cost for this kind of oil. Okay, compensating that, it can give this kind of benefit. It can save more than 1,000 units power saved per year per machine. 1,000 units of power, electricity per machine per year. And if an OEM who can say producing 2,000 machines per year, okay, with that 1 million units can be saved with this. And as I'm telling that 20 years back the machines were coming, those are not very energy efficient machines. Here we have compared a latest machine to a latest machine. If we compare with the very old machines and newer machines with this kind of technology of the fluid, so that can give much higher number, much higher number, because old machines are not saving you money. Okay, so just one question for that. In a few years back, 5-6 years back, Bloomberg has done a survey on India, and they find out how many households in India are not having electricity. Any guess number from the audience? How many households in India are not having this light, fan, AC or whatever, are not having any electricity in India? Any wild number guess? Anybody? 40%? No, in numbers. How many households in India? Someone, Mr. says 0. 1 lakh. Any other wild guess? It's 50 million, more than 50 million. Study was in 2017, so now maybe the number is reduced with our developmental things and all. But that time it was more than 50 million households are not having any electricity in India. So this can at least save 2,000, it can put light to at least 2,000 houses with this 2,000 machines per year if they can use this technology. So this is a small contribution from the fluid can save the electricity. So this is the environmental impact with this energy efficient kind of hydraulic oils. So this is our concluding slide. Our offering to the injection molding machines. We have a complete range of products, as I have mentioned. We have very good technical service support, condition monitoring, oil monitoring and testing facility. We have under the Gulf Care umbrella basically, we have 2 state-of-the-art plant, and across the geography we have depots and supplies. We have total cost of ownership kind of programs, and we have a very dedicated team. We have our M&S Enterprise is our authorized distributor in Chennai, who are catering to injection molding machines thoroughly. They have their offices and services here. We have our regional business team. Mr. Parthiban is there, and under him there is a team who is supporting this business. I'm having a team all across the India for technical services, and that's all from our side. I would like to thank IPI for giving us this opportunity to present this session here. And also I'd like to thank Gulf Oil for supporting us concluding this kind of studies, and not least that the audience who are very patiently listening this at the end of this day. Thank you very much.
Mr. Prabhakar to give a memento to Mr. Tapas.